Hello, today we will discuss metaprogramming in R. So, metaprogramming, let's see first this function. This is the normal function, and any normal function in R, what it do. So, it takes a data as an input, data like vector, data frame, numeric data, array. Okay, so there are lots of data structure present in the R. So normal function takes a data as a input and return a data as a output. Okay, for example, so this is the function which take a numeric data as a input 1 and gives a numeric data as a output. So this normal function, it is same as you studying in the universities or textbook like mathematics textbook, finance, biology, economics. Okay, so nowadays in every textbook you will see some kind of equation or function. Okay, so when I started R programming, I thought all the function works like that because everywhere you see the function in R, but it is not true. Okay, and there is something hidden gems which is present in the R, and with the meta programming we can explore these hidden gems which is present in the R. So let's get started. So what a meta programming function do, it takes a code as a data and it return a code as output. Okay, so for example, this is the code here, a plus b, and it return another code. Okay, so that is the example of meta programming in R. So first let's see what is does it mean by code. Code means instruction for a computer. So if you observe, this is the global instruction format of every machine. Okay, every architecture follow the same thing. So first it has a mode, then opcode. Opcode basically tell CPU what to do with data. So this is a verb or function for a computer, and operands is a data. So you can give from 0 to 3 argument to the funds to the CPU. Okay, so suppose let's see some example here. Rebecca says to Katrina, eat. Now Katrina is confused, eat what? So this is, if you do conversation like that, people will confuse. Okay, so this is not uh, very comfortable. So this type of conversation make no sense because okay. So now if Rebecca says eat apple, now Katrina is understood and a conversation will carry on. So you can think opcode is a verb and the operand as a object. Okay, in the, if you see in the perspective of language term, if you see from the mathematics world's view, then we can say that opcode is a function and the operands are variable. So in metaprogramming world, we see the code as a input and output as a code. So that is the compiler or interpreter do. So it convert the source code to machine code. Why we use the source code? Because it is easier to read, easier to write, and more understandable. That is the main reason. So similarly, in our meta programming world, we convert the existing R code into another R code. Why we are doing that? Maybe the existing R code is not easier to read, or maybe the existing R code is not easier to write, and there is another reason is that this is maybe it is less understandable for the programmers. Before moving forward, let's see this example. Let's see the what R actually do under the hood. So first it takes a input from user, raw text from the users, and it first it tokenize it. So the duty of lexer is tokenize the raw input of the user, and it then the parser create a parse tree, and then it goes to the semantic checker. It looks for grammars, and this is some kind of macro expansions. There are lots of things inside the R, okay. And finally we get expression, which is read by the evaluator, and you get output. So this is the things happening inside the R. To do metaprogramming, R provides some functions by which we can manipulate code. So this is the function quote. What it do? It stop the R evaluator to evaluation. Okay. So if this is the code you write, then it stop the R evaluator. Okay. Now let's see this code here. I am saving the unevaluated expression in the code variable, and so it automatically tokenized and passed. So we can see the abstract syntax tree. Okay. So if I so pass tree, it is just like a vector. Okay. And in the index 1 there is a plus operator, and the index 2 there is a 1 first argument, and third argument is also 1. So likewise you can see the abstract syntax tree of any code. Similarly, base R provides some functions to, and Rlang is also provides some function to do metaprogramming. So let's see this function here, call. Call is a expression builder function. You can build manually. So if you write like this, what it do? It create a expression like this. So for the evaluator, the first thing is a function, and the rest of the things are argument. Okay. So if you see this example, so it will create a expression like this. Let's see this code here. What I am doing here, I am building my own parser. Okay. So first it capture the argument raw text from the user, and then what I do, I deparse it. Basically I tokenize, I converted the parse tree to the raw text, then I tokenize it by the using string split function. That is the things I am doing here. Okay. Then after that, what I am doing, I create a expression here. Okay. So you can think parse tree as a vector. Okay. So in the index 3, so first I am capturing the index 3 element. So now it will become this. Okay. After that, see the call function here. After that, I wrote here as dot numeric t square bracket 1. So I am accessing here the element which have a index 1. So now it goes like goes like that in the expression, and similarly as dot numeric I am indexing 5 here. So this is my final expression. It build, and now we are able to evaluate it. Let's see this code here. So this is my parser, and I run it, and he only able to parse the binary operator, some like plus minus multiply. Other operator parse differently, so that is the reason it will not parse. So if I gave my parser as an input like 1 plus 1, it give me the output 2. Okay, and it will get error because there are, if you tokenize this here, so this is the result you get, which is this parser can't handle it. Okay, so it gives you error. So it gives you error. It will parse this successfully and this. Now let's see. I am making here string parser which takes a string as an input, and I am creating a manually expression, and then I give the expression to the R evaluator to eval it. So this is the code. So it will give me the 2. This is 1. We will explore other things regarding metaprogramming in the next video. Thank you so much.